Hello, Physics Nation. My name is Nate Larmond. I'd like to do a Khan Academy problem from a set called Net Force and Acceleration Exercise. A rolling ball slows down. What claim about the forces acting on the ball must be true? Well, you should do this experiment. Roll a tennis ball along your floor, time how long it takes in between you letting go and when the ball stops, and then just measure the distance. With these three pieces of information, you can find the acceleration. That is, displacement, the time it takes to stop, and the final velocity of zero, obviously. I'll leave that exercise up to you, maybe a different video. Anyway, any change in motion means unbalanced forces. So the sort of mathematical concept behind all of this is called Newton's second law. Whoops, F equals ma, pardon my sloppiness. So if there is any acceleration, there must be a net force. And right, there is a net force. So let's talk about what net force. Well, here's my little diagram. We have our rolling ball, big angular velocity going down to a small angular velocity. And like I said, the first decision you have whenever you encounter Newton's laws problems are, is the system in equilibrium? Is it not in equilibrium? If it's in equilibrium, there is no acceleration. That is, the sum of the forces is zero. If it's not in equilibrium, it's changing its motion. It's speeding up, it's slowing down, it's turning. If one of those three things is true, there must be a net force. There must be an unbalanced force. And just like projectile motion, we're going to break the world up into vertical and horizontal, up and down things and left and right things. So the surface pushes up on the ball and gravity pulls down on the ball. Except vertically, there is no acceleration. It's not speeding up or slowing down in the vertical direction. Because there is no motion in the vertical direction, the sum of the vertical forces must be zero. That means in this case, the normal force equals weight. They cancel each other out. We are in vertical static equilibrium, but there is only one horizontal force. So as this ball moves to the right, there is a backwards force of friction. You don't include velocity in free body diagrams. You only include forces. So there is one horizontal force acting here, friction. It's slowing down, obviously, so the horizontal acceleration is not zero. And that means there must be a net force. And that one net force, that is the one horizontal force, is friction. Friction equals the coefficient of friction, mu, multiplied by the normal force. And we'll get into that in another video. Thanks for watching. See you in the next video.